Hello students, how are you all? I hope you all are doing well. I am Mr. Prithviraj. As you all know, I am your physics teacher. In our last class, we have explained, we have gone through Fermat's principle, and in which we have discussed a lot of topics. Why a coin raises when you put water inside a pot. Okay, the image of the coin will appear. This is all because the light always want to cover least amount of distance, or it need to acquire least amount of time between any 2 points which you have taken as reference. So on the order of taking least amount of reference, what it will do? The actual position is here, so you can assume that this path is longer than this path. So what it will do, it will just refract itself out. So the apparent image will be formed here, but whereas the real object is here. That's what happened, nothing more was there. But before that, after that, we have learned so many important topics, okay, so many important lines or traits which I'll write. Please note it down. Here, the first thing is, whenever an interface comes, interface means what? Two mediums. Suppose one is air, other one is glass. Other one is suppose first one is air, other one is water medium. In this case, the point where, suppose this is it. Here it is your water medium. Here this is your air medium. So this point where they both connect each other is called interface. It is called interface. Okay. Always we need to see what exactly is interface. Okay. The interface, this is air, this is water. When they both touch each other, that is will be called as interface. Okay. So when a light travels through different medium, suppose light ray comes, it travels through different medium. What will happen? The first thing will happen is that it will change its path. What will happen, my dears? It will change its path. Why it will change its path? It's very obvious. The speed of the light decreases. What will happen? The speed of the light will decrease. So until this we have discussed yesterday, right? In our last class we have discussed until this. Now we need to cover some important lines. I hope you will note it down. When light passes from one medium to another medium, the change in speed of light is called refraction of light. So the definition for refraction is, students, please note this down. Okay, when light passes from one medium to another medium, the change in speed of light is called refraction of light. When light passes from one medium to another medium, the change in speed occurs. It's known as refraction. It's known as refraction. It's very important. Please note it down. Okay. Now, the experiment showed that the refraction depends on the speed of light in the transmission medium. The speed of light depends on the opaque density. Another important point is, refraction always depends upon what? Optical density. Yesterday I explained what exactly is optical density. Optical density means how dense the material when we look into it. If you will see kerosene is less denser than water physically. But when you will come to optical density, kerosene is more optically denser than what? Your simply called as your water. Okay, optical density of kerosene is more than that of water, whereas density of kerosene is less than that of water. So optical density is always different. Okay, it is not equal as density. Okay. Now, another important things about refraction. Rules for refraction also you can tell. Some specific rules I need to tell you. Please look into it. The first thing is, please look here. Okay, what exactly is this ray? What exactly is this ray? Here this ray is called incident ray. This is called incident ray, and this is called refracted ray. This is called as refracted ray. I hope you all can see this. Yes, it is clear. This is incident ray, this is refracted ray. What exactly is happening? This is our rarer medium. This medium is denser medium. Okay? This medium is optically rarer, this medium is optically what? Denser. When this incident ray comes, what exactly it is? This is your light ray. Which ray? Light ray. And what I told at the interface, this is called interface. This is called interface now. Yes, this is called interface now. When while coming, what exactly happens? Suppose this is the velocity of ray when it was in the medium 1. Means rarer. Suppose it is medium 1. This is your medium number 2. The ray which is on medium number 1, its speed is v1, means its velocity is v1. When it is in v2, its velocity, suppose it is in medium 2, its velocity is v2. Let us take like that. In medium 2, the ray's velocity is v2. In medium 1, the velocity is v1. Okay? If v1 is greater than that of v2, if velocity in the first medium is greater than that of second medium, then you will tell that the greater the velocity in medium is rarer as compared to the lesser velocity in the medium. That means this medium is rarer optically and this medium is quite denser. That's why light slowed down. The speed of light slowed down. This you need to understand. Now the question is, now the answer means your perception, what you should get from here. Whenever light goes from a rarer medium to denser medium, whenever light travels from rarer medium to denser medium, it will come closer to the normal. This is your normal, n and n dash. Okay, the ray of light will come closer to the normal. But when light goes from, let me draw another diagram. Look here. Suppose this is another diagram. Here, why this thing happened? This is optically denser medium. D, okay? It is optically denser medium. This is your rarer medium. This is incident ray. This is your refracted ray. This is point of incidence. This is n dash and normal. So as you can see, if light travels from denser medium to rarer medium, what will happen? It will go away from the normal. See, this angle is bigger. Why? Because ray of light is coming from denser medium to rarer medium, so it will go away from the normal. Here, when light comes from rarer medium to denser medium, it will come closer to the normal. In this way, the bending should happen. Now, an interesting topic, or the most important topic, which you will say, refractive index. That we will know. What exactly is refractive index? What exactly is refractive index? Defined as the amount of bending of light when it passes from one medium to another medium. In this way, it produces an idea how fast the light passes in a specific medium. When we speak about refractive index, it's denoted by n. It's denoted by n. And how will you define it? The definition will be the amount of bending of light when it passes from one medium to another medium. It is amount of bending of light one medium to another. Here light is passing from one medium to another. How much bend occurred? Okay, if it should go like this, no? But what exactly happened? It shifted that way. It shifted in the other way. Why this shift happened? Because of refraction. So the amount of bending occurred will be known as refractive index. Okay, and this refractive index provides an idea how fast the light passes in a particular medium. It also gives us an idea that how fast light travels in a medium. It always gives us an idea how fast the light will travel in a particular medium, right? So this is what refractive index, and several other things what we need to learn from refractive index. Okay, let me tell you some facts and some of the things which we can derive from refractive index. It's the most important topic for a 10th class. It's 9th. Okay, it's 9th, but in your 10th class, you will take this chapter as reference at each and every point. In your 4th chapter, 10th also. Okay? So please listen it carefully. C. C means what? Speed of light in vacuum. C means what? Symbol of speed of light in vacuum. Okay? When there is no medium, if it is blank, empty, at that time how fast the light will travel? That's 3 into 10 to the power 8 meter per second. MIS also you can write. Okay, this is what refractive index known as n. The speed of light in vacuum is 3 into 10 to the power 8 meter per second. And what exactly will be the symbol for speed of light in other medium? That is V. V means what? Refractive index of, speed of light. Speed of light in medium. Any other medium you can take, like glass, kerosene, benzene, or you can take quarters or water. Okay, these all things, there the speed of light differs. Okay, that will be taken as v. But speed of light in your vacuum or air is always c. Rest all will be taken as v. Okay, now let us know what is absolute refractive index. What exactly is absolute refractive index? Absolute refractive index is speed of light in vacuum by speed of light in medium. What is absolute refractive index? Alright, you can write short form. Speed of light in vacuum by speed of light in medium. Absolute refractive index is speed of light in vacuum divided by speed of light in medium. Okay, symbols. Then it is a ratio between two similar physical quantities, so it is dimensionless in nature. See, whenever we are writing speed, we are giving a unit called m/s. Whenever we are talking about force, we are telling that Newton. Whenever we are talking about distance, we are telling meter. So it has units. All physical quantities are units. What about the refractive index unit? What is the unit of refractive index? Nothing. Why? Because this is also speed, this is also speed. This speed of light in vacuum, this speed of light in medium. They both unit will be meter per second only. So they both cancel each other. So this will be dimensionless. Dimensionless means it has no unit. Okay? Refractive index n has no unit. If somebody asks you what's your weight, you will tell 50 kg. Right? If somebody asks how much kilometer you have traveled, you will say 500 kilometers. Okay, if somebody asks what is the refractive index of glass, you will tell 1.33. That's it. What is 1.33? 1.33 is the refractive index of glass. Is there any unit? No sir, there is no unit. Why there is no unit? Because they both are divided by what? Similar kind of physical quantities. Is that fine? In our next class, we will learn relative refractive index. In our next class, what we will learn? We will learn relative refractive index. Until then, bye bye. See you again.